This is numbers 12 and 13 on the study guide. So on number 12, we've been asked to show that we have a parallelogram. And we're showing it to prove essentially that x is 6 and y is 4.5. So when you're looking at this, if we plug this in, let's see what happens. We're going to go ahead and take RV. And RV is 8y minus 8. And we're going to put in the y that they tell me to. So we're going to do 8 times 4.5 minus 8. So we'll throw that in the calculator. Oops, hold on just a second. And what I get is a side of 28 units for RV. Now let's go ahead and look at what ST is. ST is 6y plus 1. So again, we're going to take that 4.5 and we're going to put it in. So we're going to do 6 times 4.5 and then we're going to add 1 to it. What we get is 28 units. Now what that means is that RV is actually congruent to ST. That's important because that's one of the attributes for our parallelogram, but we got to keep going. We got to do this for the other side as well. So let's go ahead and take our S, which is 7x plus 6, and we're going to put that x value that they gave to me in it. So x is 6. So 7 times 6 plus 6. So again, you're going to do 7 times 6, which is 42, plus 6, which is 48. And then let's do it again for the VT side. The VT side is 9 times x minus 6. So it's 9 times, we already said that the x was going to be a 6 that we plug in, minus 6. So when we have 9 times 6 minus 6, we're going to get a total of 48. What does that mean? These two sides are equal in length, which means that if their measures are equal, it also means these segments are congruent. So now, what I've got is this set of sides, my opposite sides are congruent, and I've got this set of sides, my opposite sides are congruent. So what I can say is RSTV is a parallelogram because the opposite sides are congruent. All right, let's go into number 13. On number 13, it says, show that this is a parallelogram, and they give me yet another set of measures. So we're going to do the same thing. We're going to plug it in. So when I'm looking at plugging this in, the measure of angle G is equal to 2m plus 31. Now they tell me my m is 12, so I'm going to do 2 times 12 plus 31. We're going to throw that in the calculator. So 2 times 12 plus 31 is equal to 55 degrees. Let's go ahead and find the measure of angle K. In K, they give me this n value, so it's going to be 12n plus 11, so it's 12 times the n they give me is 9.5, and we're going to add 11, so 12 times 9.5 plus 11 is 125 degrees. And then we're going to do it one more time. The measure of angle J, we've got 7m minus 29, so if I do 7 times the m of 12, minus 29. Let's see what we get there. So 7 times 12 minus 29, and what I get is 55 degrees. Now, if you look, 55 degrees plus 125 degrees is 180, which is significant here. Because when we're looking at this thing here, we had a theorem that said if we have a quadrilateral, so there's my four-sided figure, with angles that are supplementary, that means they add up to be 180, to a consecutive angle, that must mean that this is a parallelogram. So we can now say GHJK is a parallelogram because we have a quadrilateral with angles supplementary to the consecutive angle, which implies we have a parallelogram. So there's your reason. So GHJK is a parallelogram because it's a quadrilateral with the angles that are supplementary, meaning they add up to 180 to this consecutive angle. And because we've got both sets of them equal 180 to this consecutive angle, we've got ourselves a parallelogram.